Today I am going to explain the experiment number 7 of physics 1, inelastic collision in one dimension. So this experiment is from your chapter 9. So in that chapter you will study the concept of collision. We have two types of collision, elastic collision and inelastic collision. So in this experiment we are going to study some information about inelastic collision. My dear, in inelastic collision what will happen? The conservation of momentum will satisfied, but the conservation of the kinetic energy is not satisfied. Only this difference. If you want to write the definition for this inelastic collision, momentum is conserved but kinetic energy is not conserved. But in case of elastic collision, momentum is also conserved, kinetic energy also conserved. So what is our principle? Today we are going to verify the principle of momentum. That means we are going to prove the conservation of momentum for inelastic collision, which happens in one dimension. If you see the schematic diagram, what are the apparatus today we are going to use? We are going to use air track. We are going to use photo gate 1, photo gate 2 with two gliders. You are going to take two gliders and you are going to push this glider towards the second glider. When the first glider crosses the first photo gate, this photo gate is connected with the timer box, so the speed of the first glider will be recorded there. When the first glider come in contact with the second glider, what will happen? Collision takes place. After collision, what will happen? Both will stick together and both will travel. When the both gliders will be crosses the second photo gate, this photo gate, the second photo gate is connected with the second timer box, and this speed, that means the both glider speed will be recorded in the timer box. Clear? So today we are going to give the program in the timer box as speed 1 gate. So in this experiment we are going to use two timer boxes. How many timer boxes? We are going to use two timer boxes. In each timer box you are going to give this program. Clear? Okay, let's just see the table. If you see the table, we have to fill this entire table. In this experiment there will be no graph. So if you want to fill this table, the most important thing, you have to find the mass of the glider and you have to find the mass of the second glider. So mass of the first glider and mass of the second glider, you have to measure by using triple beam balance. Once you find these two, it will be easy to fill this, because this U and V you can get from the timer box. So the rest of the calculation, you need this M1 and M2. So what I'm going to do, I'm going to explain how to measure the mass of the two gliders by using triple beam balance. So if you just see this is our first glider, this is our second glider. So how we can just to say which one is first one. If the glider with the sharp needle, you have to take, that is your first glider. The gliders without sharp needle, without sharp end, is nothing but your second glider. So first we have to measure the mass of the first glider. Once you measure, you have to measure the mass of the second glider. So what I am going to do, I am going to show you how to measure the mass. My dear, this apparatus is called as triple beam balance. If you just see, there are three beams. There are three beams. This beam record the mass in terms of 10. The middle one recorded the mass in terms of 100, and the third beam recorded the mass in terms of 1. Clear? And this part is for the adjustable. If you want to adjust this triple beam balance, you have to adjust this. By that, you have to make this line exactly coincide with 0. So if you want to set this line to 0, you have to touch this one. If you adjust this knob, this will be exactly comes to 0. So first step, if you want to measure the mass of the glider, what you have to do? You have to fix this line to 0. So this is almost coincide. So I don't want to touch anything. If you want to adjust, you can touch only this. Clear? Understand? Now what I am going to do? I am going to place my first glider over here. Now what happened? After I put that first glider on the pan, you can see this line is moving to the upward. So now what we have to do, we have to adjust these three beams to make this line exactly coincide with this 0. So first step, you have to touch the hundreds. So what I'm going to do, I'm going to move this 100 level. That means initially it is 0. I'm going to move this to 100. Is there any change? Nothing. So what I'm going to do, I'm going to move this to 200. What happened? It's immediately fell down. So what I have to do, I have to take this 200, again I have to move this to 100. Now what I have to do, because again we have to make this to 0. So I'm going to touch the 10 levels. If I move to 10, what happened? Is there any change? Nothing. I'm going to move this to 20. Is there any change? Nothing. 30. Nothing. 40 is nothing. 50, nothing. 60, nothing. 70 is nothing. 80, no. 90 is nothing happened. So I'm going to move this to 100. So still you can see only the level will be little bit coming. So now I'm going to choose the 1 levels. So I have to move. You can see the line is little bit moving now. Just a minute, I will set. You can see it's exactly to 0. So what should be the value? You can see here 100, here also 100 grams, so 200. If you see the middle of the arrow, 206.3, 206.3. So what I have to do, the mass of the first glider, if you just see the table, the mass of the first glider 206.3 gram. You have to see 206.3 gram. Likewise, you have to measure the same method to measure the mass of the second glider. So what I'm going to do, I'm going to take the second glider, I'm going to replace the first one with second one. I have to push all this to 0. Again I have to measure with 100. 100, 200. Now I think you can see the line exactly matches. So what should be the value? 206.1. 206.1. So what I have to do, 200 is here, 6 values here, but center there is an arrow, it is exactly at 0.1. So 206.1. So what I am going to do, I am going to write it here, 206.1. Clear? So the first step, we have to measure M1 and M2. Once you measure, what we are going to do, we are going to calculate the value of U and V. So what you have to do, you can see the apparatus. Let's I just give some information about your apparatus. Again, we are going to use the air blower, and this air blower is connected by a tube with a air track. So once the air is coming through the tube, air will be coming out of this small hole, and when it comes out of the small hole, what will happen? The friction between this layer and this layer will be reduced. So the object will be sliding very smoothly. And then we are going to place the second glider. So this is our second glider. You have to place in between two gliders, and the distance between the two photo gates, it's not a matter. You can fix some level of distance. It's up to you. There is no particular measurement about the distance. If you want to know the correct value, you have to just place these two, and this much distance is enough between two photo gates. So what you have to do, you have to take your first glider, just put it at the end, And please place the second glider here in the middle of the two photo gate. And first photo gate is connected by the first timer box, and the second photo gate is connected with the second timer box. Clear? So now what will exactly happen? I'm going to push this. I'm going to push the first glider. So when the first glider crosses the first photo gate, the speed of the first glider will be given by the first timer box. Okay? And then you can see here, when the first glider come in contact with the second glider, what will happen? Both will stick together, both will travel. When both will crosses the second photo gate, the speed of the both glider will be given by the second timer box. Clear? So what I'm going to do, listen carefully. I'm going to place my first glider here. I'm going to place my second glider in between the two photo gates. I have to give the program. So what program? Speed 1 gate. So I have to press this red color button one time, second time. If you press second time, you will get the speed. And then you have to select the mode, 1 gate. This is the program. And if you press the star, the apparatus is ready to start. Likewise, you have to give the same program in the second timer box. Speed 1 gate. And then start. Now what you have to do, you have to turn on the air blower. And the air blower should be in the maximum level. When air is coming, what will happen? You have to hold the first glider by your finger. Otherwise, what will happen? It will be moving slowly, and finally it will cross the photo gate. It will take the reading. So what I am going to do, I am going to hold these two gliders with my hand. So first of all, I am going to turn on the air blower. What exactly happened? Air is coming out of the track. Now listen, my dear, I am going to push the first glider. I'm going to push little bit with my force, and when the first glider crosses the first photo gate, the speed of the first glider is measured nothing but U value. When the first glider come in contact with the second glider, both will cross the second photo gate. By the time, the speed of the both gate will be indicated as V, that will be given by the second timer box. So now what I'm going to do, let's we just take the reading for 1 set. But the most important thing here, you can see there are different small slots are there. You have to apply this value. Why? You can just have a look of the table, delta. So delta is given as 10. So delta is nothing but a small grams. So 10 grams you have to apply only to the second glider, not in the first glider. So if you just see, there are different slots of masses. We have 10 grams, 5 plus 5. So what I am going to do, I am going to put 1 5 this side, another 5 this side. And then I am going to place in between the two photo gates. Clear, my dear? Now what I am going to do, I am going to place the first glider to the extreme end. Now both timer box, we fix some program. Now we are going to take the reading. Clear? So I am going to push the first glider. My dear, listen carefully. I am going to push the first glider. Listen carefully. Just have a look of this. The speed of the first glider is 6.1. So what I am going to do, the U is the speed of the first glider, 6.1. And V, what is the V? Both gliders stick together when it crosses the second photo gate. That is nothing but V. What is the value of V? It's 3.9. So what I am going to do, I am going to take this value. I am going to write this value here, 3.9. The rest of the things are calculation. So listen carefully. I am going to work out the calculation here. My dear, listen carefully. M2 plus delta. M2 plus delta. So what is M2? This is my M2. 206.1. Delta, what is my delta? 10. So I am going to fix that value on my calculator. So 206.1 plus 10 gram gives you 216.1. So I have to write this value here. Clear? Now we are going to calculate the momentum, initial momentum and final momentum. So what is the formula? The formula for the initial momentum is M1 multiplied by U. What is our M1? 206.3. What is our U? 6.1. So I am going to multiply this mass 1 with my u value, which is nothing but my initial speed of the first glider. So 206.3 multiplied by u value. What is our u value? 6.1 gives you 1258.43. So I am going to write this value here, 1258.43. Likewise, we have to calculate the final momentum. We have to calculate the final momentum. My dear, this is unit, okay? Don't get confused about these letters. This is unit. So we have to use only this formula. What is that formula? M1 plus M2 plus delta. What is our M1? M1 is this. M2 plus delta. It's here. So this value plus this value you have to add and then multiply with V. So now I am going to add. Listen carefully. So M1 206.3 plus M2 plus delta 216.1 equal multiply by our V value. What is our V value? 3.9. So what is our answer, my dear? 1647, 1647.36. Now we have to calculate the error percentage. P initial minus P final divided by P initial plus P final multiply by 100. So my P initial is this, P final is this. So we just work out on the calculator. P initial value. P initial is 1258.43 minus 1647.36 divided by 1258.43 plus 1647.36, which gives multiply by 100. My error percentage is 13.38. My dear, I already told you, if your error percentage is between 0 to 20%, it is acceptable. So if your error percentage is between 0 to 20%, then you can say momentum is conserved. Momentum is conserved. If your error percentage is greater than 20, then you have to say momentum is not conserved. So likewise, you have to repeat the same experiment for different values of small grams. So what you have to do, again I will show you for one reading. You can just see this glider. I am going to take both glider. I am going to remove these small masses. Now it is our 20 grams, am I right? So take 20 grams, that means 10 here, 10 here. So we have to substitute 20 grams, that means 10 grams here, 10 grams this side. So I have to place in between here. Likewise, you have to push this. When the first glider crosses the first photo gate, U will be measured by this, and then when both will stick together, when it crosses the second photo gate, V will be measured by this. We just take one reading. I am going to slowly push this. Listen carefully. You can see my speed of the first glider is 9.7. My speed of this both glider is 5. So I am going to write it here. You can see here the speed of the first glider 9.7. So I am going to write 9.7. My speed of the second glider, my speed of the both glider when it crosses the second photo gate is 5. So I am going to write 5. And likewise, you have to calculate M2 plus delta. What is my M2? This is my M2 plus delta. What is the value of delta? 20. So you can see the calculator. My M2 value is 206.1 plus 20. What is my answer? 226.1. So I have to write 226.1. Now initial momentum. M1 multiplied by U. M1 is this. U is this. Am I right? So 206.3 multiplied by 9.7 gives you 2001.11. So 2001.11. And here we have to measure the final momentum. M1 here, M2 plus delta is here. So I am going to add these two. After I add these two, I am going to multiply with V. So listen, 206.3 plus 226.1. I'm going to add, multiply by 5. What is my answer? 2162. 2162. Now again I'm going to calculate the error percentage. If the error percentage is between 0 to 20, then you have to say momentum is conserved. So I just apply the value here. Initial momentum minus final momentum. So initial momentum 2001.11 minus final momentum 2162 divided by initial momentum 2001.11 plus final momentum 2162 multiplied by 100. See, my error percentage is very small, 3.86. Actually here we got negative, but when you are using the absolute sign, negative absolute value is positive. So I just take only the positive. So when you compare with the first mass and the second mass, still our error percentage is less than 20%. So momentum is conserved. So likewise, you have to repeat the experiment with different small grams in the second glider. Repeat the experiment, get the answer. So in this experiment, there will be no graph. Only you have to see this answer. If this answer is between 0 to 20%, just to say the momentum is conserved for inelastic collision. Understand? So momentum is conserved for inelastic collision. So this is the explanation for the 7th experiment. That's it.